Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Hello everyone, welcome to another tutorial of the Docker series, and this time we are going to discuss Docker networking here. Today we are using a new tool actually to draw better Docker networking. So it's kind of very important topic actually, which means that I don't know how to change this text actually, text file heading one. Okay. So Docker networking is a very important concept indeed. But before we study this, or before we actually get into the now of the topic, the most important thing is that how really Docker works, yeah, networking works. So just bear with me a little bit. So just want to actually wanting to check that how this thing works, but it seems very complex right here. Okay, but don't worry, we are going to sort this up. Okay, Docker networking. This is our topic actually for today, and this is a very important topic. But before you understand what is actually networking, so let's jump into the networking then. So what is in general a networking in normal scenario means? So this is very important because all the concepts really complete concepts or really depends on this concept here. So if you don't know what is networking in general, then it's very hard actually to. Let me just draw something and tell you that what does networking mean? When, for example, I search here computer, maybe. So this is, for example, one computer. Let me just create another computer, and these both computers are connected somehow, and they are connected with the Ethernet cable, let's say like that. And when they are connected with Ethernet cable, they can communicate with each other. They can communicate with each other. So they can communicate with each other. That means that it is network. Very simple, right? When two computers connected to the Ethernet cable, a small Ethernet cable, and when they can communicate with each other, this is a simple network. But what happens is, for example, you are in room number one of your home, and you want to connect five PC. Let's say like that. You want to connect multiple PCs here. One is here, one is here, one is in center, one is like here. You have multiple computers, and let's say like that you want to connect them together. How you can do this really? So one concept is that you can do it with help of switch. So now let us um, switch is something very similar to this device. So there are multiple switch coming into the market. So now what this switch means that you can essentially plug your cables into, you can plug your cable into, you can, okay, you can pretty much, do this. You can, all the computer could be connected to this. And then, for example, okay, and now this is very hard. Yeah. And now you have this diagram where actually you could essentially connect to the whole computers, right? And with help of cable, now you're connected to the internet to this. So, for example, this is. Let me just say that this is. This is. vertical. So let me say that this is actually nothing but this is your room number one. In room number one, you're sitting right here, right? And you can connect with the help of this switch to all the computer. So when you're connected to the same switch and communication is happening, how communication is happening? So what you call it in technical term? In technical term, for example, in technical term, all computer connected to same segment. Same segment are called local area network, which means that if a computer or if the computers are connected to the same local area network, so might be you have heard about LAN, local area network. Since this is the same segment of the same segment, this is same network segment. This whole segment, room number one, is the one network segment, and all computer attached to this switch essentially communicate with each other through this switch, which means that they are on the same network, and that's why they can communicate to each other, no problem. Everything is going to fine. I will also tell you that how you access the internet or the external world of internet in your home as well with a similar analogy, but let's first uh, keep things simple. And here actually you have this computers, like 5 computers connected to the switch, and you can communicate with each other. This is local area network, which is great. Now, for example, let's say like that you have another room number two. Let's uh, let's group this. Let's duplicate this one, and for example, no, it's not possible. Let's first group it, and then maybe duplicate this and do like that. So really sad. Just pardon me for a moment. Right now, for example, you have here room number two. You have in your home, you have second, let's say like that, room, room number two you have here. Now what you want to do is that you want to communicate with both of the room, because now they are isolated network. This network is isolated. This network isolated. These machines can essentially talk to each other, but room one and room two cluster of network, or the room one segment of network in technical term, should be somehow communicated with help of some data layer link. So data layer link is nothing but operating system software level moduling that says that so when they created in 1980s the internet, and then they specify that how actually data transfer and what's the protocol, what is the modularity, and there are like 7 different layers they have created for one information leaving to the other computer or device, and then that's how these method has been developed over the time, and they called the the specific layer through which data is communicated is data layer link. And for that actually we need actually something called bridge. So for that actually we need bridge. Let's say like that, this is now bridge, right? This is now a bridge. Now, what is the purpose of this bridge? This bridge actually communicate with, let's say like that, it's create a bridge as very much evident from this name and very simple from the name. This is the bridge which create a bridge between these two. And what does that do? Any call from this computer to this computer actually first goes through this bridge, and then this bridge facilitate do the DNS resolution. What does DS resolution do is that DES and domain name server. This is local domain name server. For example, we have name of file computer, computer one, computer two, computer three, and when MAC address of computer one actually goes here, and it's automatically recognized that this call or protocol is any information packet are being requested or being sent from the computer number one from the room two, and this router since is connected to room one only because this is the bridge between the two. And then this means that you want to ping, let's say like that, you say that room two computer one, room one computer one, room two computer one, they want to connect to each other, and then DNS software or whatever bridge software is installed in there, or simple software is installed in there in network terminology, and then that's how actually you do this networking stuff. So that's a normal networking. So what we have learned in this, in the networking, we have learned actually that what is actually mean by this, um, what is a bridge, right? Now you understood what is bridge because this terminology is going to be used in the Docker actually. And the Docker by default create a bridge in the virtual machines because if you create an internet, there is a way to create all the networks similar to the virtual machine because for example if we work in the virtual environment we can create a DNS or the bridge which is here which act like a physical bridge mostly, but it is not real, but it is a layer or it is a simulated kind of bridge which acts very similar like physical one, but this is logical one or this is act like that or simulated into network bridge. So coming down to the line, now we have understood that what does the networking means, how networking in the Docker works, very similar. So Docker container are just created. For example, let's say like that I have one more virtual machine. Let me create a virtual machine. For example, this is my virtual machine here. Let me call it VM here. In this virtual machine, I have container. Container one is running here. Container two is running here, and container three is running here. There are three container altogether. Now, when I create a bridge, simple Docker network bridge. So I just create the the bridge here, and easy peasy. This bridge is going to facilitate. This is bridge, and now what I can do is that very easily I can now communicate with each of these container. So no problem at all because this bridge. So with this similar concept, the bridge also in Docker works very similar. But first, if by default you create a container in one local host, what happen is that, for example, if I create a text, the IP gateway is going to be created, and then subnet is going to be created, right? Might be you have sometimes seen that there is a default gateway 192 plus 168 plus 1 plus 1, and then there is a subnet, and then these in these sequence these IPs are given to this computer always. So that's how these are the when you create a new network by default, when you just create a Docker in your host virtual machine, it's going to create a it always going to create a default internet gateway and default internet a bridge which is virtual, and this bridge is doing all this stuff. This is network driver actually, and this is going to make sure that whatever Docker you create, it's going to give IP to this Docker container, this Docker container, this Docker container, and every Docker container get IP, and IP has one gateway, and gateway IP is given to this bridge, so this device, and the subnet also given to this device, and all the internet addresses are within this sub network range. So now the question arises: what is the subnet and what is the IP? What is the gateway? Now, subnet is nothing but normally if you see, right, if normally you see that there is a gateway address always, it's our IP address, IPv4 address always look like IPv4, IPv6. And what is the difference between these two? IPv4 address come from the very old, like 1980 or 1990. They thought that there are not gonna much device in this world, and then that's why they have given some IP to that range. But over the passage of time, there are billion and trillion and petatrillion of the devices, and these a 4 byte IP address is not sufficient. That's why they come up with the other idea that we should create another IPv6 which could cater more devices, because every single device you have on the earth must have unique IP address. Let's say like 19.2168 plus 1 plus 1, or 000 plus 0.0 is my gateway or my subnet, and always you see that slash 16 or slash 12 in the IP address. What does that mean? This is simply that how much number of new IP could be assigned using this gateway. So this is the masking. This is called subnet mask. And what do we mean by the mask? That whatever number here is written is equal to there comes something. Okay, I go here. Ah, I can create text here. Okay, good. And that means that, for example, I have 16 bytes. And this is now another story that how these bytes are going to calculate. But let me just tell you that how you do this. For example, the formula is 2 raised to power 2 raised to power 32 minus whatever the number of subnet CIDR, CIDR block. Let me CIDR. CIDR block is nothing but this much IP addresses can be attached to. Let's say like that if 32 minus 16 is 16, and 2 raised to power 16 means that 2 multiplied by 16 times 2, 2 by 2 by 2 by 2, and let's say it is 65,000, a random guess. I'm not gonna go to the math right now, but let's say 65,000 address we can create. Now, what does that mean? That now this gateway with this subnet with slash 16 bits with the CIDR block, we can create almost this much number of address we can create to this CIDR block. So that is what it means. Now, great. So now we have conceptually done with first type of network, which is bridge network. We can create how you can create bridge. It is very simple. You just go create a Docker network, create bridge name. So that's how you create a bridge, and your bridge automatically gets subnet mask and everything. We are just shortly going to practice this and demonstrate this, but let me just first conceptually draw all the concepts. So in the Docker, it is similar. This is nothing, fancy. Then there is other type of Docker network, which is this is bridge number one, and this is another which is host. I don't want to get into the detail that why it's needed, because there's very limited use cases of that host network, which means that whatever your host network is, always your Docker container get that network without there any other networks. So there is barely any use case in the industry. That's why I just leave it. And other than that, there is a very important second type of network, which is very important here, is that overlay network. Now, what does overlay means? We need to again draw something. Overlay means that, for example, this is a virtual machine. This is VM here, and this is VM2, and this is VM3. We have 3 VMs here, right? We have let's just create a little bit space here. Okay. 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 Well, let's say like that. We have this swarm network. We have this swarm network. Like we have this swarm cluster here. Let's call it SWRM swarm cluster. And as we know that one computer is master, this is worker one, this is worker two. We have two workers, and inside they have their own network. For example, somehow this master node is directly connected to this and directly connected to this two, and also connected to both of computers somehow. And there is vice versa communication as well. That's why you initialize Docker Swarm. If you don't know what is Docker Swarm and how the network create cluster, go to the video in the description and check this video where we have discussed in detail what is Docker Swarm and how does and what does it do. But now, for example, the similar network, kind of bridge network, isolated network are created on the each PC. And since they are on same actually Swarm cluster network, which is called overlay network actually, which is called overlay network, and that's why they could communicate to each other. Very simple. That's why they are able to communicate to each other because the overlay network has been created. This is another type of bridge, but this bridge is more efficient, and this bridge is very fancy, and you can actually what you can do is that you can create that overlay yourself, but when you initialize Docker Swarm in it, then it's automatically created. And you can also modify it. The beautiful thing about it that you can modify it. Let me just tell you that, for example, this is the node and I just give it, right? This is one node, this is second node, this is third node. These are the node actually created with the overlay network number one. And now this network is easily able to communicate with each other with help of this bridge network, which is called here, for example, call it let's call it let's call it a fancy bridge, a more beautiful bridge, which is overlay type, and this has ability to create a multiple because this is VM number one. What we here have seen is only one virtual machine and container within it. But here the IP address of this virtual machine is different. IP address of this virtual machine is different. They are different computer, they are different laptop. And now, because this is one small room number one, as we have given this example, room number one, this is room number two. And similarly, this is room one, this is room two, and this is room three. And there are multiple computer within their room they can communicate, but when you need to communicate with each other, this is the overlay. So that are the major type of internet story Docker Swarm uses, and that much is important to know. Let us now see in practice that how you can manage and create and check the IPs and their values. That is also very important. So yeah, that's pretty much it. And that's how Docker really works in the networks. Let me just tell you something more about that. Okay, our virtual machine has started now. I have started this because it's taking always much time. And okay, we are here. Let's and, okay, let's log in as root logger. Okay, and for example, now if I show you that existing network of Docker, because this is my master machine, I have initiate here, I initialize the Docker Swarm as well, and I have also run multiple container here as well. So in both of the cases, we have already multiple network must be here. So for example, if I say Docker PS, there is nothing. If I say Docker PSA, well, there are some container which are not running clear. Then for example, Docker and always module name. Module here is network and list. As you can see, this is a beautiful example of what I was talking about here, right? So as you can see here that this is the bridge network, this is the bridge ID here, this is the driver type of driver here is local Docker GW bridge. Well, this is the bridge we have created manually. Host means that virtual machine network. This virtual network machine network is that if I go here and if I network in network setting, you can always see that what type of network it is because I'm kind of connected somewhere because that's why I need to communicate to net. Otherwise, there is a restriction. The network I'm connected to right now is kind of secure. That's why it's corporate network. That's why I cannot simply do the bridge. But it's not important. Then actually, this ID is the ingress you see here. This ingress is always the overlay type and is always scope using by this swarm. That's what I was talking about the overlay bridge, and this is the most practical network actually nowadays in practice. This is actually null because or none. None means that sometime for the security reason you need to create a Docker where you don't want some internet or any kind of network capability at all because it is highly secure or due to your privacy concern you don't want to create it. Blah blah blah. Whatever reason could it be? Any reason could it be? Don't want to create it, yeah, but right now, yeah, that's the network. Now if I show you what I mean by that here, let me just do that. And you see here similar concept is working here, and here's the VM, very simple. Let me just little bit, I don't know how you zoom them, but okay, there is no way to zoom them essentially, which is very sad, but you can see that if I show you here something, which means that Docker and Docker network, and then inspect, and then ID of that bridge. So if I paste this ID here, it's gonna give me a greater details. And here you can see that gateway, what I have talked about the gateway, and this is the subnet, and there is CIDR block that is 16. Now, whatever container I have created or I will create, all those container are going to, let's say like that, gonna get the IP address with this prefix, gonna same only 1, 2, 3, 4, 5, 6, 7 up to 53,000 because we have discussed that this network capability has 53,000 or 65,000 networks or Docker to be installed or to be attached here with this network. And that is what the CIDR block means actually. And you can also get greater detail. This is the if I create a new Docker, let me just create a Docker file with Nginx Alpine. How you do that? Possibly, I don't know. Docker run d slash big P means random port mapping. Uh, Docker, duck here, Docker run detach mode random port mapping, and then for example network is default, otherwise we can always say your network and name of the network, but let's say it's bridge is default. Just for the purpose I'm going to name this docker which is cont1, just create multiple container 1 And then, for example, I'm saying that this is the name of the container and in the end, image engine engine next. Okay, Nginx Alpine. Why I'm using Nginx Alpine? Because Nginx Alpine is a very lightweight container. That's why there is nothing, no other. So as you can see, it has it given me a random port mapping. Name is the container one. And now let's try to get the IP, or let's try to get inspect Docker inspect. Docker. What for the commands? Actually, Docker. These are the command. Docker inspect and Docker PS here and Docker inspect and ID of this container. And now you can see here that IP address, that is what I'm talking about. The IP address is from the same subnet mask. The subnet mask I have shown you before, it has gateway this one, right? And that's why it's giving the address. But the subnet, if you see, it is 00. Might be there is a subnet somewhere, but yeah, there are too many details actually here. But the most important thing is that host IP port and all those stuff. And here you can see that how they are from the same network. And if, what I can do to show you that I just create maybe another container on the same network, and I call it network number container number 2, and it's going to create container number 2 Docker PS2 container con1 con2, and for example I go to Docker exec exit Docker exit, and then I'm saying that I need to get first IP of this container number 2 con2, then host name slash small I. Okay, that is my container IP 172.77.3. And now I show you, for example, this is my container 2 IP address, and right now I'm on container number 1. So if I'm on container number 1, and I can also get the IP, which is 2. And now if I ping, so you can also run any command actually with the Docker exec. You can run bash, you can run bash interactively with IT, and you can also run whatever Ubuntu normal Linux command here, and it's gonna perform and give you output straight away. Let me just use a simple, very simple, because con, we are on the con 1, we are executing con 1, which is here, and we are pinging con 2, and we need con 2 IP. Con2 IP is nothing but 172 plus 17 plus 0 plus 3. And there you go. You can see that there is a complete connectivity between them, and it can just communicate with each other because they are part of the same network bridge. Now let's say like that they are not they are on same network bridge, and that's why they are able to communicate. Might they are in same room, same router, same network bridge. They are isolated with their isolated container, but they are connected with the bridge here, and that's why they're able to communicate. Now, if I create another network, let me just create another network straight away. And the command to create the network is very simple, which is docker network create. Here's the command docker network, right? Create a new create driver name, whatever driver name, host, overlay, bridge, whatever it is, bridge, and my second, yeah, my new, yeah, my custom, BRIDG, my custom bridge. And there you go. Now there is new bridges created, and I say dock your docker network and then ls. Now you can see that there should be another name, my custom bridge. Now, for example, I can create another docker con3 here. Maybe I here write network, my custom bridge, and name of the container is container3. Okay, container run pd. I don't know where the network is. Network, I guess you mentioned you con3 after the con3. The network should con3 is the name, and then here might be network should come as network and my custom bridge maybe. Yes, so another container has been created, but this time the network we have chosen a different one. Now let's see Docker PS here. And as we can see that the con3 is there. Just I go there and I get Docker exec and then uh, where I'm con3. Okay, con3 host name dash I. So well, now another as you can see now that the story has been changed completely because now they are not from the same network, rather than their gateway network has completely changed to 1790. And if I say Docker network inspect and my custom bridge, let's say like that, and you would see that here the subnet has been changed completely because instead of 17, it has started with second block with 19. And that's how you can really know that this is your second one. And for example, if I now ping from container 2 to container 3, let's say like that, docker exec docker 2, which is no, container 2, which is part of the gateway 1, and I want to ping to this ID here, which is docker 3 here. I paste it here, there should be a no response. You see, it's pinging, but there is no response because there is no um, direct connectivity between these two. So yeah, you have seen that how this works. So yeah, this is very beautiful. We have created a new network, and in the new network, we have tried to ping one network from the other network. So for example, here we have created automatically another subnet, and in this subnet, one subnet could not really, you know, work with the other subnet. For example, if I duplicate this and here is the second subnet somehow, right? So there is a second network. There is no connectivity at all here, right? The VM is same. The VM same. The gateway, this is bridge one. Let's say like that. This is this is BRIDGE. This is bridge one, and then this is really bridge two, and there is no connectivity. And there is really there is really no connectivity between these two at all. There is no connectivity between these two. Why? Because they are different bridges right there. So they have different bridge right here, right? So that's how you analyze them. And what else? So now let's come to this Swarm cluster, and they have a style of network is the overlay network, and overlay network has been specified for this. And you can either change the configuration. You can also change some stuff here. And yeah, that's I guess pretty much it about the networking basics. If you go a little bit deeper down, you should MacVLAN. MacVLAN is nothing but little bit more advanced kind of network work which make this lighter, but there is also not much use case. So next topic which comes in my mind is Mac VLAN. This is another type of network normally used in the Docker world. This is also kind of important because if you're using Docker Swarm only, I mean, honestly speaking, that nowadays nobody use Docker Swarm as well, only 10 to 15% people. Yeah, but still it is a big number and you need to know. And if you don't know the basics, then definitely it's very hard to understand about this stuff. But the thing is that Mac VLAN is have come into the place when, for example, you say that oh, how that connected. When you say, for example, that well, um, custom custom subnet, you need custom subnet. You don't want a subnet IP. You need custom range of max IP. So, for example, you need your own CIDR block I.E own CIDR block. You need your own CIDR block. For example, you are saying that well, it's a really overkill to have it's really overkill to have that much number of capacities. I mean, that really doesn't make much difference, or that really doesn't make that much difference. But in general, you could say that you know you can say that well, I want to do that. I want to restrict the IP. I want my own subnet, and I want some customized rule, and want a little bit more latency because I don't need 65,000 container on one single virtual machine. Doesn't make sense. Might be through this I can achieve a little bit more efficiency, but technically speaking, the beauty or the marvel of this Docker is that they manage these things automatically and make them so lightweight that you really don't need to worry much about, and they are not creating much overhead. That's why they are into the market. But still, if you want that you need to create something custom, then you can really create this custom thingy here, and simply pretty much you in the driver here, you just say that my driver is really here is my driver here is Driver is MacVLAN, and subnet is, for example, this one, this range, and cider block is this much. Let's subnet this, and you cannot say cider, rather you can get gateway. My gateway is this one, right? So you can customize this, and then it's right create my overlay or my Mac VLAN, my Mac VLAN. You supply this command, and so pretty much it's creating a new network for you with the customized configurations, and you can later on attach this to the any nodes. For example, if you're working in the cluster, you can attach this cluster because you can just say that please attach my complete swarm when you init swarm to this network, and then it's going to attach to this network, and then now your swarm is part to the overlay kind of network with VLAN. So that is pretty much Mac VLAN is doing. Mac VLAN is essentially a bridge network, a same copy of bridge network. It is exact same copy and exact same feature what you what bridge is giving you, but on top it gives you ability to customize the subnet and gateway range of IP addresses, and also style of IP addresses. Even though these styles must be conformed with the protocoling of the network, like 4 blocks and very similar, only you can change the number of MAC address and something like that. Sometime you need that, and that's why that's that. These are the command you can do here, and yeah, that's pretty much it. Thank you very much. Have a nice day, and please stay tuned for the more tutorials. And this is just short overview of the Docker networking. But in real time, people use Kubernetes, and Kubernetes take care of the networking under the hood by own, and they have very sophisticated way, even third-party driver and third-party application integration, security, and a lot of other stuff. But if you know the basics, it's gonna help you in the greater detail that how networking works and how IP addresses work, how IP4 and IP6 are different from each other, how cider blocks different, what is mean by local area network, what is mean by external network. And last, if I promise you that I'm gonna tell you that how you can communicate to the external world. For example, just 2 minutes more. And for example, you're sitting in the room 1 and room 2, and you're connected to each other. Now, locally, you can send communication or packet of message from this computer to this, or any of this computer to this. But what if you want to connect to the external world? For the external world, you always need a router. For example, Vodafone router or any router, router, router. Okay, for example, you're working with the Vodafone router here, and with Vodafone router, you're here completely connected, and this has its own kind of IP address, 192.1.6.8.2.1. This is the default gateway in this scenario. For example, this is Vodafone, and this Vodafone is ultimately connected to the server, Vodafone server. So Vodafone server is sitting somewhere here, for example, and Vodafone server is sitting here, something here, and then this server has some software installed. It can assign the IP to this device, and this device is ultimately then kind of connected to here. This device is connected to this network, or let's say like that to this router here, right? To this router here, and you have connected with this IP address, and this IP address is connected to computer, and this computer is ultimately connected maybe from Germany to the USA with another computer through the ocean and cables and whatever. For example, world, WORLD. This is this computer is somehow with help of a cable which is running through the oceans and running through all the big cable that are connecting to the server to the whole part of world, for example. And each part of world has multiple server. They are physically really connected with cables. And when you send message with the WhatsApp here from this computer, to your friend sitting in the USA, and then it's first go here, get IP address, this IP address translate to this server know that this traffic is coming from this, and that's why you call them internet service provider. The Vodafone, the other service companies are IPS, they are internet service provider. They have their server connected physically with Ethernet cable to the whole part of world. And your friend sitting in the USA, he might has any other internet service provider like Vodafone. They have their own server, and these two computers somehow with the oceans and with all the landline completely connected with the cables. Might be you have heard about that internet blockage outage due to some fish has eaten the cable in the ocean or something that or disrupt some animal disrupt that. And these computer are really connected with similar like our room analogy with real cables with whole part of world. There is no other way around. These all computers somehow some way are connected to this cable. But might be last things coming in your mind that if this is the case, how then wireless works? My mobile is not connected to any stuff here, and when I send a message, how comes that comes true? And this is again the thing that wireless is nothing but just a signal emitting by your phone, and your phone or just your phone is connected here. Your phone is really connected somehow via wireless to this computer here, and it's getting a wireless signal from this router, and wireless signal are working on the GMS or other frequencies, and they are nothing but a frequency, and this frequency is connecting to this, and that's why they are just sending the high message, and high message is transmitted over the frequency megahertz to this router. This router send them to here, and you send them, and this is being sent to the your friend sitting in USA. Right. Sometimes you are saying that I'm in the public internet, but there is no router involved. But they also might be connected to any sort of wireless internet connecting, and either if either it is a signal booster or whatever, uh, booster or like whatever it is. Maybe have you seen the electrical how you stands or the transmitters like this tall thingies. So they are essentially also connected somehow. They have wireless connection here, and they are also somehow connected to an internet service provider, and internet service provider somehow connected to the cables, and these cables are connected to the board. And then even if you're working with the wireless too, you are still really connecting here with these physical cables. So that is what very important to understand that how networks really works. And this networking principles really works similar in the virtual mode, in the bridge and with the name of bridge in the virtual machine with the Docker. And they have different names according to the needs. This is the summary. And sometimes you can customize it, sometimes you cannot, but that's overall idea of this Docker here. So thank you very much. Bye.